Introduction to acid and base. My dear students, there are many sensation centers on our tongue to identify the taste of substances. We are acquainted by the taste of the substances which we eat from food. For example, lemon, tamarind, vinegar or amla have sour taste. These substances have sour taste due to the presence of compound, and that is called acid. Acids are soluble in water and they are corrosive in nature. Animals and plants also possess acids in them. Acids present in foodstuffs are called natural acids or carbonic acids. These acids, being weak in nature, are called weak acids. Some acids are strong in nature. They are inflammatory or caustic. Example, sulfuric acid, that is H2SO4, hydrochloric acid, that is HCl, and nitric acid, that is HNO3. These acids are also called mineral acids. The skin gets burnt when their concentrated solution falls on skin. Similarly, their vapors, if inhaled, can be harmful to health. Strong concentrated acids are converted into their dilute acids by slowly adding them into water. Such dilute acids are less harmful than their corresponding strong acids. Base. Students, if you taste dilute solution of baking soda, you will find it astringent or bitter. Substances having astringent or bitter taste and slippery to touch are called bases. For example, lime water, that is CaOH2, baking soda, that is NaHCO3, caustic soda, that is NaOH, and soap. Bases are completely different from acids. Chemically, they have properties opposite to that of acids. They are also inflammatory to skin in their concentrated form. We know that the distilled water is tasteless. Water is neither acidic nor basic. Indicator. The substances which are neither acidic nor basic are chemically inert in nature. Touching or tasting of acid or base is very harmful, and hence typical indicators are used to recognize them. The substances which change their colors in presence of acid or base are called indicators. Indicators in laboratory. In the laboratory, litmus paper is mainly used to test alkali or base. This paper is made by an extract of lichen plant. It is red or blue colored. Blue litmus paper turns red on dipping in acid, and red litmus turns blue by alkali. Similarly, phenolphthalein, methyl orange and methyl red are used in laboratory in solution form. Methyl orange indicator becomes pink in acid and yellow in alkali. Phenolphthalein remains colorless in acid and becomes pink in alkali. Universal indicator, which are in liquid state, change their color in the presence of acid and base. Let us see the changes in colors of indicators in the presence of acid and base. The blue litmus paper turns red in the presence of acid but remains blue in the presence of alkali. The red litmus paper remains red in the presence of acid but turns blue in the presence of alkali. Methyl orange is orange in color but turns pink in the presence of acid and turns yellow in the presence of alkali. Phenolphthalein is colorless. It remains colorless in acid, whereas it turns pink in alkali. Methyl red is red in color. It remains red in the presence of acid but turns yellow in the presence of alkali.